today we're going to present about our topic, which is power quality enhancement in the renewable energy system using active filters. So my name is Muhammad Alif Aiman bin Mokhtar, and I will be taking the introduction. So for the introduction is the global changes to the renewable energy is an important response to the urgent needs to fight the climate change and reduce the usage of carbon emission. Renewable energy systems such as solar photovoltaic and wind power has gained the widespread usage for their sustainability to replace nowadays fuels. However, integrating this renewable energy source into existing electrical grids poses significant obstacle. This variation can lead to the critical power qualities issue, including harmonic distortion, voltage sag, frequency deviation, and system instability, all of which has unpleasant effects on utility providers, industrial operation, and end users. As the height for renewable energy is the first globally, ensuring the stability and reliability of power grids has become the top priority. Addressing the complexity of renewable integration requires the advanced technology solution capable of mitigating power quality issues and maintaining the system performance. Active filter, particularly silent key, has emerged as a highly effective and adaptable technology to meet the requirement of this challenge by dynamically compensating for harmony, mitigating voltage instability, and responding fluctuating energy inputs. Silent key helps to maintain consistent power quality, ensure the efficient operation of renewable energy system. This filter not only enhance the reliability of the power grids, but also play the key role in supporting the widespread adoption of renewables, driving the world closer to a sustainable and low carbon emission in future.
So thank you to my friend and Assalamualaikum and good afternoon. So now for our group, I will talk about our control strategy design for our simulation for our design. First, I will talk about overview of control strategy design. So basically, designing and active filters involve a systematic strategy to ensure it meets the requirements, performance, efficiency, and Cost effectiveness. So there are three things that we ensure to make sure that our simulation is uh, gets the requirement performance, efficiency, and cost effectiveness. First, identification of power quality issues. We identify the power quality of each component in the simulation uh, to make sure our uh, component did not fry. Second, design strategy. We design our simulation in the we design our circuit simulation in our LT Spice. Third and lastly is to simulate and optimize. So basically, after we done all the things that I have said, we simulate our circuit and try to optimize the circuit if there is any problems. So that is for our overview and control strategy design. Next is implementation and methodology. So basically, after we simulate the circuit, we try to implement on real life. So implementation of active filters, the power system is a critical process that involves various phases. So we carefully plan the hardware and software design and the real world testing. So the detail for methodology is the system analysis and requirement specification. First, we try to analysis the system that require this the requirement specification. Next is design and modeling. We try to design and model based on our simulation. Next is hardware and component selection. We try to choose the hardware that is the most usable and the most cost effectiveness for our project. Next is testing and calibration. We try to test each component first before the and calibrate before using them. Next is deployment, which is we try to build the circuit first and try to make sure the circuit is the same as our simulation. And finally, monitoring, maintenance, and optimization. So after we do the design, we build the circuit in real life. We try to monitor to make sure there is no problem, and if there are any problems, we try to maintenance it, and we try to optimize its uh, its power, its management. So basically, that's all from me for our group about control strategy design. Next, I will pass to my friend. Thank you.
Greeting to madam. So my name is Aswadas Biman Harun. So you can see here, this is for, I'm gonna talk about our design and calculation for the activity design. So for the frequency, we can set here in 1 kilohertz, and our resistor and capacitor for the resistor is ours we are set for 22k, and for capacitor is 0.01 F. So after that, we can go through the FC. So formula FC in 1 over to 1 per 2 pi over RNC. So we can just put our RNC value here, and so we can get the value left for 723.43 kilohertz. So for the V in is 30, and so we can go to the V out. So for the V out, F per FC per the root 1 plus bracket for FC and F by FC and over 2. So we can just put here the value 1 kilohertz and 723.53. So just put, and so we can, after the total is the total is 0.81. So after the VR, we can go to the V average, because we got the V out. I mean the V out is same, it is same again. So I put the gain as my the VR as a gain. So the formula for the V average 1 divided root 2 by VP and by gain. So we can just put here 30 and 0 and 1. So the value is, so the total is 78.2 volt, and the CL is V out divided V in. So we just put, so we got, I mean, just insert our value, so we can get the 0.027. So go through the dB for dB 20 log ACL. So we just insert the value, so and we get the negative 3.14. Negative, yes. So this is for our circuit. This is V in, this is V on, and our R1 and R2 we got put here because we are on activator, so we got capacitor here. So I pass to my friend. So thank you.
My name is Muhammad Fadli. In this video, I will explain about our circuit. As you can see here, we construct the three-phase AC circuit. Why we use this particular source? Because we use solar panel output source. For the voltage source, we use solar panel voltage, which is 30 volt for one solar panel. For first circuit, I will show you the non-harmonic circuit. Why we why we choose this specific circuit? Because we need to generate the noise waveform. This, as you can see here, this voltage source, uh, we use the independent voltage source as uh, this one, arbitrary behavioral voltage source. And to generate the non-harmonic, um, I use this inductor and resistor with the inductor value of 1 Henry and resistor with 100 ohm. For the active filter, we choose the high pass silent key because the filter this filter can no. This filter uses a voltage amplifier with a high input impedance and low output impedance. So it is perfect circuit for this task. This circuit also a perfect filter to filter the noise. Silent key filter can be cascaded easily and the stages don't affect each other tuning. And that's all for my video, and I will pass to the next video.
Hi, I am Muhammad Naeem, and I'm going to talk about the result of assignment active filter for electronic tool. As we can see within the LT Spice, the bottom part is the circuit and the top part is the graph of the V in, which is VN002, and V out 2 is for the V out. We can see within the graph itself, there's some unstable voltage we can see from the V in, but on the V out we can see a clear and more redefined stable voltage with across the graph itself. Because of this, it's easier for us to control and to use the V out as it has a lower voltage than V in, and at the same time we can see the V in, the peak, the above peak at the lower peak is not the same as the V out that have a 14 voltage of positive 40 voltage and negative 14, as it is more stable and much more easier for us to use. That's all for me. I'm gonna pass to the next speaker.
Okay, so for the conclusion is the integration of renewable energy system into the existing electrical grids is the critical step forward to achieve a sustainable low carbon emission. However, the inherent variability of renewable energy sources such as solar power, photovoltaics and wind power introduce a significant power quality challenge that cannot be ignored. Issues like harmonic distortion, voltage sag and frequency instability risk to the reliability and efficiency of power system, affecting both utilities and end users. To counter this challenge, advanced technological solutions are imperative, such as Selinki active power filters have proven to be an innovative and an effective tool in maintaining power quality amidst fluctuating energy inputs by dynamically compensating for harmonic and stabilizing voltage under variable conditions. Selinki enhance grid reliability and facilitate the seamless integration of renewable energy. As the global go through renewable continue to rising, the adoption of technology like Selinki will play a crucial role in supporting the transition to a greener energy in future. By overcoming the technical obstacle to renewable energy integration, we can ensure a resilient, efficient and sustainable power grid capable of meeting the growing demand for the clean energy while addressing the pressing challenge of the climate change of our world. That's all from us. Thank you.